Doing good.
Okay, we were on chapter 3, that was simultaneous equations. We discussed equations and inequalities. The portion related to inequalities is left: linear simultaneous equations, quadratic simultaneous equations, simultaneous equations on graphs. We did these 3 parts. One of the method was elimination. The other was substitution. And the third method is graphical method. Any confusion in these 3?
No.
Do you remember this word discriminant?
Yes. I
What do you
remember.
remember about this?
If I remember correctly, the discriminant is whether b squared minus 4ac is equal to, above or below 0, right?
Yes. So b square minus 4ac tells you if the roots are real or equal or not real. These were the cases. If it intersects at 2 points, it is greater than 0. If it touches, that means it is a tangent, is equal to 0. If it does not touch, that is less than 0. And smiley face or sad face depends on the coefficient of x square. So we'll practice few questions, and indirectly we've already covered this in chapter 2, which was quadratics. Okay. So let's straight away go to the questions. Do you remember these inequalities? These are from IGCSE. Let's solve one of these
Yes.
as well. So we take x on one side, 5x minus x is greater than equal to 20 minus 9. So this is 4x greater than equals to 11. X is greater than equals to 11 by 4. Number line, when to shade the circle or when leave it like that. When it is greater than equal to or less than equal to, we shade this circle. And when it is only lesser than or greater than, you leave the circle unshaded. Shading means it is included. Do you remember the sketching part, completing the quadratic equation into completing square form and then sketching it? Have a look at this. Quadratics. And here it is, the sketching part. This, do you remember these questions? Y is equals to 2x square plus 4x plus 10, taking out 2 common to make the coefficient of x square as 1, then completing square form. Positive 2 in this part tells you that it is a smiley face. Turning point is minus 1 comma 8, and then you go for the intersection of the x's, x-axis or y-axis. General form was a bracket x minus h whole squared plus k, where a tells you if it is a smiley face or sad face. H comma k is the turning point. So this was the sketching part, and we are going to solve this for a quick recall. Find the range of values of k for which the equation this has no real roots. So if it has no real roots, what is the limitation? Anyone? No real root. B square minus 4ac.
Mm. There are no real roots when it's below 0.
No real root. B square minus 4ac is, yes, less than 0. Question number 5. It says find the range of values of k for which the equation x square minus kx plus x square minus kx plus k plus 3 equals to 0 has no real roots. So in case it does not have any real root, b square minus 4ac is less than 0. That is, discriminant is less than 0. So b is minus k minus 4, a is 1, and c is k plus 3 less than 0. K minus 4k minus 12 is less than 0. We have another quadratic form, so we'll go for completing square. Or midterm breaking is also possible. For 12, it is 1 into 12, 2 into 6, 3 into 4. So we can choose this one. Adding or subtracting 6, we can adjust it to 4. K square minus 6k plus 2k minus 12 is less than 0. Multiplying these two, we get negative 12x square. Adding these two, we get negative 4. So k, this is k minus 6 plus 2. K minus 6 is less than 0. K plus 2 times k minus 6 is less than 0. First bracket equals to 0. Second bracket equals to 0. So k is equals to 2 and k is equals to minus 2 and 6. When k has these two values, the first equation, it does not touch the x-axis. Second part says find the range of values of p for which the roots of the equation are real. It says roots are real. So what sign will we use? Px square plus px minus 2 is equals to 0. B square minus 4ac, this is 0. What sign should I use in this empty space?
Greater than?
Say that again.
Greater than?
We will use greater than and equal to both. How do we know this? It says the roots are real, but it never mentioned that the roots are real and distinct or the roots are equal. So we're left with no choice but to use greater than and equal to both. So roots are real, solving for the unknown. B square minus 4 into A into C greater than equals to 0. P square plus 8P is greater than equal to 0. Taking out P as common, p plus 8 greater than equals to 0, first bracket, and then we have second bracket. So one is p is greater than 0, the other is p is greater than equal to minus 8. This is not the final answer. We always have to check if it justifies or not. There are two ways we can do this. Draw this line. Coefficient of x square is p, which is 0 in one case and minus 8 in the other. So 0 minus 8. We have these two values. One way is this A, B, C. We use these values and see if we get the correct response or not. And I'm using this thing. P square plus 8p is greater than 0. If I talk about this section A, may I use value minus 1? So see for yourself, square of minus 1 is 1 and 8 into minus 1 is negative 8. Negative 7 is greater than or equal to 0. Is it true or false?
It's false.
Only Muhammad is responding. The two students, are you getting it? Yeah, yeah.
Yes.
Okay, this is false because negative number is not greater than 0. So I'm putting a cross over here. Area A is rejected. Then we have second option between 0 and minus 8. I am using number 1. So p square plus 8p is greater than equals to 0. When we use 1, we get the answer 1 plus 8 greater than 0. 9 is greater than 0. So this is true. 9 is greater than 0. Area B is selected. The third area for C, this was for A, this was for B, and for C, if I choose, like, okay, I made a mistake and you didn't mention it. 0 must be on right hand side. Negative 8 over here. So minus 1, when we cannot choose minus 1. It should be less than minus 8. Changing it quickly. If I choose minus 9 squared plus 8 into minus 9 is greater than or equal to 0. 9 times is 81. And this is negative 72. And the difference is 9 is greater than 0, which is true. First part, then second part for B, p square plus 8p is greater than 0. I am choosing minus 1. So minus 1 squared plus 8 into minus 1 is greater than 0. 1 minus 8 minus 7 is greater than 0. This is false. So B goes around, and for C, p square plus 8p is greater than 0. I am choosing 1. So 1 squared plus 8 into 1 is greater than 0. This is 9 greater than 0. That is true. So when we follow this thing, you can see that we have x, which is less than negative 8. P is less than equal to negative 8 and P, which is greater than 0. Compare these two. It was saying that it is greater than negative 8, but it turns out to be less than negative 8. Whenever we solve the inequality, we always have to check if we have these two inequalities in right order or not. In 99.9% of the cases, the sign of the lesser value reverses. The other way to check it is you draw a line and we see that the coefficient of squared number is positive. So it is a smiley face. The other thing, we have these two values. One was 0. This was minus 8. And this sign is greater than 0. Greater than 0 means the shaded region lies above the line. So we have two split answers. So just by looking at it, I can say P is less than equal to minus 8 and P is greater than equal to 0. greater than equal to 0, less than equal to -8. So sign of this inequality, which we just algebraically solved, changed. Yes, Mahad?
So in this type of question, is it usually like a hidden trial method, like you did with the line?
Usually the sign will change, the sign will reverse. We always have to check it. We always have to check it. In exam, you may face one of this question. So it won't be hectic. During practice, yes, in every question you have to check it. So you may find it that it's a lengthy question. But in exam, it is only once. Okay, now how the inequalities would look like on graph. These are exactly the same way you drew the graphs for linear or quadratic equation. For example, if I say that we have these two questions, y is equals to x square plus 2x plus 3. And the other equation is y is equals to 2x plus 7. Let's quickly have a look how they will appear on the graph page. Before opening that, if I just make a guess that suppose it looks like this and this, does it make sense? One graph is quadratic, the other is linear. If the question tells you that x square plus 2x plus 3 is greater than 2x plus 7, you will always have 2 points of intersection for quadratic and linear if it is not a tangent. So at these two values, let me say this is A and this is B. For this given condition, X is either greater than B or X is less than A. Any disagreement? Like if I say B is 9, so when I will use value more than 9, the graph is above this line. If I say value of A is like -2, when I use value less than -2, again the graph is above this line. Between A and B, the line is greater than the graph. It lies above the graph. Is this thing clear?
So could you just explain this part one more time? I'm a bit confused.
Okay. Let me consider a simpler one. If I say we have y is equals to x square plus 2, and this graph exactly looks like this, symmetrical around y-axis, and the point of intersection is 2. And I use another graph, y is equals to 7. So this is y is equals to 7. So x square plus 2 is greater than 7. For this condition, point of intersection, there are 2 points of intersection, 1 and 2. If I solve this, is greater than 7, this is x square greater than 5, and x is greater than plus minus square root 5. So this is, Madam, coming to you, plus square root 5. This is negative square root 5. Yes, Mad?
If y equals 7, shouldn't x squared plus 2 also equal 7? So why is it greater than 7?
These are two differences. One, if it is equal, then these are just the equations. When it is greater than or less than, this is the part we are concerned with inequalities. I'm explaining it. Let me write if over here. The other case would be x square plus 2 is less than 7. We will discuss these two one by one. Okay. I'm erasing it just so we don't mix it. I've solved these two equations. Equation number 1 and equation 2. Solving these two equations, the point of intersection is plus under root 5 and minus under root 5. So if someone asks you x square plus 2 is greater than 7, if it is greater than 7, I can say that the value of x is greater than square root 5, or the value of x is less than square root negative 5. Any objection in this case? When we are talking about our first value, this value, when I am on right hand side, is it true that x square plus 2 is greater than minus 7?
Yeah.
And when we are on left hand side of negative square root 5, is it true that the value of x square plus 2 is more than 7?
On which side?
Yes, Mahad?
I'm asking on which side?
On left hand side. On left hand side of negative square root 5, is the value of x square plus 2 more than 7?
Wouldn't it be less than negative square root 5?
One point is you can no, the value of x, whenever you chose the value of x, we are comparing the values of y. If I choose any number on left hand side of minus 5, let's say minus 6, I chose minus 6. So when we plug in the value, y is equals to minus 6 squared plus 2. This is 36 plus 2, which is 38. And 38 is clearly more than 7. If we choose a value on the right hand side of square root 5, let me say I choose a value 3. On right hand side, I choose a value 3. So y square is equals to 3 squared plus 2, which is 9 plus 2, 11. That is again more than 7. Point of intersection is negative square root 5 and positive square root 5. At these 2 points, they have equal values. So when you go to right hand side, this is your sketch, and these are the points of intersection. Point A, point B. When you go to right hand side of point B, the value on the curve is more than the value on line. When you go to left hand side of point A, the value of the curve is greater than on line. And when you are between them, when you are between A and B, there the value of line is greater than the curve. Okay, suppose we have Mahad here. Mahad, you're taking this slide and you're moving along this curve, and it is given that Mahad never leaves this curve. He's not jumping in here. So Mahad, when you are at point A, are you above the line? When you are at point B, are you above this line or below this line? When you are at point C, above or below?
Below the line.
Below the line. So these are the 2 marks. Before crossing this, you started with the value of x over here, and when you reach the value A, you were on the line. When you crossed it, you were below the line. Excuse me. When you are at point B, you are again on the line. When you crossed it, you are again above the line. So the question, if the question was x square plus 2 is greater than 7, so negative square root 5 and positive square root 5, your answer is that for x less than square root 5 and x greater than square root 5, this is true. If we change our consideration, if we change the demand of question, if we say x square plus 2 is less than 7, then we will say for -5 square root is less than square root 5. Is this condition clear?
Yes, sir.
Yeah.
Okay. So there is no difference between these two values. This entirely depends on the condition, if it is greater than or less than. So there are these two ways: either you sketch the graph or you consider substituting the values between your inequalities. Now look at this question. If I tell you we have only one line, let's choose this. If I say the curve is less than the line, what will the values be? Point of intersection is -2.2. The point of intersection is 4.8. If the curve is less than the line, what will be the values?
Repeat that question one more time.
If we consider that the curve is below the line, the curve is less than the line, the value of the curve lies below the line. So these are the 2 points of intersection, 1 and 2. So at these 2 points, their values are equal. At these 2 points, their values are equal. So when the value of x is between -2.2 and 4.8, the curve lies below the line. If the condition is that the curve is above the line, so at this portion marked in green, the curve is above the line. So the value of x will be more than 4.8, or the value of x will be less than -2.2. Is this point clear?
Yes.
Okay. Can you draw this sketch for these three?
Can we use GeoGebra with that as well?
Have to use software to draw the grid, or should we do it by hand?
You don't need GeoGebra for this. These are all three are linear. If it comes in exam, that will be without software. Consider this. This is y is greater than x minus 2 first equation. Y is less than 4x is second equation, and y is less than 5 minus x third equation. Recall y equals mx plus c. M was the gradient and c is the y-intercept. So if you consider the first equation, you can say see y equals x and the intercept is -2. So y equals x and -2. Just a simple sketch. Intersects at -2. If you see at the second equation, which is y is equal to 4x, the gradient is 4 times and the y-intercept is 0. Nothing is written there, so the y-intercept is 0. It passes through the origin but the gradient is more than that. First line, it had a gradient of 1. Second line, it has a gradient of 4. Third line, the gradient is -1, but the y-intercept is +5. So -1 and +5. So y is less than -5 minus x. So you have to shade the region which satisfies all three inequalities. When we talk about the red line, the region is below this line. When we talk about the line in green, the region is again below this line. When you talk about the line in blue, the region is above this line. So above this line, below this line, and below this line. This is the only region which satisfies the three inequalities. Any doubts?
And so when these questions appear in exams, do we have to draw it accurately, or will it just be a rough sketch?
Sketches, only sketches. The difference between,
Will be marked on the labels, right? And
yeah, this is the
everything else.
sketch. And if it would have been a plot, then we will clearly label all the x's, numbers, points of intersection. Or either we'll draw this on a grid paper, graph paper. This is always sketch. It's never plotting. Okay, let's see question number 6. It's already drawn. This sketch shows the graph of the straight line with equations. So y equals x plus 1. I know that the gradient is 1 and y-intercept 1. So it is clearly the black line. Then y is equals to 7 minus x. Gradient is negative, y-intercept is positive 7. It is clearly the red line. And the third line, x is equals to 1, the vertical line drawn in blue. Work out the coordinates of the point of intersection of the function. So it is already drawn, and point of intersection, one point is this, x is 1, y is 2. The other point, red and black, the intersection is x is 3 and y is 4. And the third point is this, x 1 and y 6. Are the point of intersections clear?
Yes, sir.
B part tells you to write down the set of inequalities that represents the shaded region shown in this sketch. So is the shaded region above or below the red line?
It's below the red line.
It is below the red line. So may I change this equation with this inequality? The red one. Yes or no?
Why would I don't understand why we would change it from equals to smaller than?
Because the question says write down the set of inequalities. So this will actually
Understood.
change to this. What about the black one? Is it below or above? The region is below the line or above the line?
Is it above the line?
It is above the line. So y is greater than x plus 1. The last one, blue line, x is equals to 1. Is the region on left or right?
On the right.
On the right side. So this is x is greater than 1. Any disagreement in these three inequalities? Okay, now I'm adding one more thing. Whenever it is a solid line, we say greater than and equal to. Greater than and equal to. And whenever it is a dotted line, only then we ignore the equal to sign. Okay. For example, if we have these equations, y is equals to 2x plus 3, number one. Let's say y is less than equal to 2x plus 3. And the second equation is y is greater than 5 minus x. And you are asked to sketch these two. So y is greater than equal to 2x plus 3 will look like this. The gradient is 2 and the y-intercept is 3. And the other line, y is greater than 5 minus x, the y-intercept is 5, but the gradient is negative. So these will look like this. When there is no sign of equality, it is a dotted line. And when there is a sign of equality, it is a solid line. So less than this solid line and greater than that, we are left with this region. This is the shaded region which satisfies these two inequalities. Clear?
Yes, sir.
Okay. Now let's just go through if we have skipped anything. Next exercise. So if I mark few questions, will you be able to solve them today and we'll discuss those if you don't get the answer? I'll solve few questions with you. We still have time. Question says 2k equals minus 2 are two simultaneous equations where k is constant. Show that y is equals to minus 2. How will you go about that?
First, rearrange the equation. Is that the first step?
Yes. 4kx plus 3y is equals to minus. It says show that y equals to. Show that y is equal. May I multiply the first equation with 2 in order that I can have same constants for x. The first equation is now 4kx minus 2y is equals to 8. And the second is 4kx plus 3y is equals to minus 2. Then subtract the two equations. This was positive becomes negative, positive becomes negative, negative becomes positive. Subtracting these two, we eliminate x, and minus 2 minus 3 is minus 5y, 8 and 2 is 10. Y is equals to 10 by negative 5, y is equals to negative 2. Shown. We an expression and in terms of constant values in 2kx equals 4, value of y is negative 2, 2kx equals 2, kx equals 1, x is equals to 1 over k. So in terms of k. Clear?
Yes, sir. I understand.
Can you please solve this question right now? Question number 2. X plus 2y equals 3 and x square minus 4y square equals to minus 33. Please solve this now and Do we have the same answer?
Yes.
Yes. Sir, do we have to find two values for x and y, or do we only need one?
To our surprise, this is one value, and the reason would be these two are tangent. This line is
Uh,
tangent to the curve.
I'll
When
just
y
write
square
another.
disappeared, you're left with only one value.
Okay.
If it would have been there, we will be getting two values either using quadratic formula or midterm breaking. What about Muhammad Abbasi and Yahya? Are you getting the same
I got the same answers.
answer?
I also got the same answer.
Okay, let's have an overview of these questions. Given the simultaneous equations, again same, hence find a pair by eliminating. When it restricts you, definitely go for the same method. Question number 5. It says, given that 3 power x is equals to this, show that this. Okay. This is a little different. Let's do this. Three raised to power x is equals to 9 raised to power y minus 1. It says show that x is equals to 2y minus 2. So if I say 3 raised to power x is equals to 3 squared y minus 1. And then I say 3 raised to power x is equals to 3 raised to power 2y minus 2. And then we go for the comparison of powers and we say this. So shown first equation and the second equation is already given, x square plus y square equals 7. X square plus y square, equals to y square. So solving these two. Yes, Abbas.
You've just done x equals y minus 1. Why did you do x equals 2y minus 2? Why did you convert it to that?
Chapter 1 indices. Look at this. 3 raised to power x is equals to, may I write 3 square? Convert 9 into 3 square. And then what the rule was, if we have x square power 7, this was equal to 14. The power actually multiplies with this. So we multiplied 2 with y minus 1. Y minus 1 is power of this 3 squared. So this actually looks like this, which is 3 raised to power 2y minus 2.
Why? Why did you need to do this?
Why we need to do this? This is rules of indices. A raised to power x raised to power b, powers are multiplied with each other. And why we multiplied or we made this? Because we cannot compare 3 with 9. So converted the bases. This was 3. This is 3. So convert these two bases and then compare. Is it clear? In next part was solving these two equations. Luckily, x is already subjected. Equation 1, equation 2. So 2y minus 2 whole squared is equals to y square plus 7. A square plus b square minus 2ab equals to y square plus 7. Rearrange. Y square minus 8y plus 4 minus 7. 3y square minus 8y minus 3 is equals to 0. So multiplying these two, you get 9. Solving this, 3y square minus 9y plus y minus 3 equals to 0. Going for midterm breakings, y minus 3 plus 1, y minus 3. And then we have 3y plus 1 times y minus 3 equals to 0. 3y plus 1 equals to 0 and y is equals to 3. Y is equals to negative 1 by 3. Now we have two values, so we will go for two values of x. X is equals to 2y minus 2, our main equation, x equals to y minus 2. So 2y is negative 1 by 3 minus 2. I'm using my calculator for this. 2 into negative 1 by 3 minus 2 is negative 8 by 3. So one value is negative 8 by 3 and negative 1 by 3. The other is 2y minus 2, where y is 3. So 6 minus 2, y is 4. So x is 3, y is 4. These are the two values. Please practice this exercise, mixed exercise. Inequalities are there, simultaneous equations are there, lesser than, greater than, and discriminant. This is summary of chapter 3, and then tomorrow we'll start with chapter 4 after discussing any problems you face. Okay.
Okay, sir.
Thank you so much. See you tomorrow.
No.
Take love Hafiz.
We'll be right back.